Hello, ladies and gentlemen. Now we're going to be looking at the trend of ionization energy. So we defined this in notes 3, and ionization energy is how much energy it takes to remove the outermost valence electron. Okay, so let's take a look at our periodic table here. We learned that the group number tells us how many valence electrons we have. So all of my elements in group number 1 have 1 valence electron. All of my elements in group number 2 have 2 valence electrons. As I go further down in my periodic table, and once I get to group number 8, I have a completely full outer energy level. So let's look at how that relates to ionization energy. When we're looking at our data here, we have the atomic number on our x-axis, and we have the ionization energy on our y-axis. We also have the periods labeled to help you see what's happening as we go across a period. So starting here, let's start with lithium, because lithium is my first element in my second period. So here's lithium, element number 1 in period 2. Here's the ionization energy. When we go up to beryllium, we see that we're going up. So beryllium is going to take more ionization energy than lithium. It kind of drops a little bit, and then it continues to go up. So we can see that as we go across a period, our ionization energy is actually going up. So as I go across my period, my ionization energy is increasing. Now let's talk about why that is. Lithium is in group 1. It only has 1 valence electron. So it's not being held as tight to the nucleus as, let's say, neon, which has 8 valence electrons. So this 1 valence electron is going to be, it's just not going to take as much energy to get it to lose that electron. Okay, it's just not as tightly held. Whereas if we go across our period, we're getting more and more valence electrons that are going to be attracted to the nucleus. So if this is my nucleus and I have electrons on the outer energy levels, if I only have 1 electron here, okay, it's being held close to the nucleus there, but it's not being held as tightly as if I had, let's look at having several electrons. So the more electrons we have in our outer shell, the tighter they're held to the nucleus because of the opposite charges. So it's going to be harder to lose them. Okay, and we also know that all of these elements that are on the left side, they're metals. And what we know about metals is that they want to lose their electrons to become positive ions. So if they want to lose their electrons, that means they're going to have a lower ionization energy. Okay, now our elements on the right side, these are the nonmetals. And nonmetals are really close to having that full octet. So they want to gain electrons. So they're going to have a much higher ionization energy because they want to hold on to those electrons. And this graph right here supports that. So we already looked at what happens as we go left to right, showing that as we go left to right across our periods, that ionization energy increases. Let's look and see what happens as we go down. Okay, so if I'm focusing on just group 1 elements, so that's lithium, sodium, and potassium, and then these guys here, they're also in group 1. I just don't have them on my periodic table here. So if we look at their ionization energies, And I know that it's not a drastic change, but we can see that lithium is at 500. Sodium, it looks to be a little bit lower. Potassium, it's lower than 500. Rubidium, it's still lower than 500. And then cesium. So it's going down, it's just not going down as drastically. So as we go down our groups, we can see that the ionization energy is decreasing. Ionization energy is going down. Right? Now let's talk about why that might be. If I have a lithium atom, it has only one energy level. So there's its one little valence electron. If I have sodium, sodium is two shells with one valence electron. This electron is further away from the nucleus than this electron here. So this is lithium and this is sodium. So because this is a larger size, the distance the electron is away from the nucleus is further. So it is not held as tightly to the nucleus. So that means it's going to take less energy to remove that electron than it would to remove this electron. Okay, so the bigger the atom, the lower the ionization energy. Okay. All right. All right, ladies and gentlemen, hopefully that helps clear up what ionization energy is and how we can read a graph to understand that relationship.